So I've been working for Arup for roughly 10 years, and I've been in the design space for about 7 years. And Vincent's, he's basically the wise old man. He's been doing this for 10 plus, and he's the one that you want to direct all your questions to later. So just moving on to slide 3, give a bit about the background of the project. So the project was based in central Queensland in Townsville, and it formed the section 4 of the Ring Road, which was a link between the Bruce Highway from Brisbane to Ingham, and it was a bypass of Townsville City for a freight route. So basically you can look there, it was the final 11.5 k's of the 22 kilometre section, included 3 interchanges, and it was a dual highway, 4 lanes. Improved PED facilities, travel times, flood immunity, and looked to obviously reduce congestion on the local road network. The project had 480 plus civil drawings, 150 plus civil structural drawings, and within the project we had a design road base for 12D, and we had a design road base for CAD. The idea being there that the 12D base would have no post-editing, and the CAD base would have all sort of, if there was any barrier that wasn't modelled or things like that, would be done in there, so you weren't always overriding your models. Next slide was the project team. So we had a small little project office. It was a lean team. The idea being that just get in, hit it hard, and try not to obviously overspend. We had the designers and the drafters all sitting in the same office, and we also had the inclusion of the Seymour White interface manager there with us, which was excellent. It allowed us to sort of bounce ideas back and forth with them. Anyone that worked in a project team knows how valuable this can be. So some of the goals for our team and our office was obviously an interdisciplinary coordinated model, clash mitigation as opposed to detection. So idea being there that we wanted to think ahead and try to avoid those clashes where possible, and doing that through just design iteration, and a bit about construction methodology. So how do we use 12D? The good thing here, so 12D, we had a project inception plan. So this is where we created a 12D project plan that sort of detailed how we were going to go about our modelling, who was going to do what, how we were going to deliver this thing, timeframes, reviews, all that sort of stuff. And then the 12D was used for all the road alignments, all the permanent works, the drainage design, over 109 culverts, and 75 longitudinal drainage networks, and then also the utilities, and we also piloted 12D synergy on this project as well. So this is just a bit of an overview of the project. So it was split into 3 areas. We had the southern interchange, the northern interchange, and the main line, and that just allowed us to basically have multiple designers working on the project at any one time, and we also had a master project where everything was shared into for all our plotting of all our PPS for our long sections and cross sections and outputting to CAD. That little red arrow there pointing to that little dot on the design is Bridge 70. So this project had multiple bridges, and Bridge 70 was one of our more complex bridges. And Vincent's going to take over from here and talk a little bit about Bridge 70, some of the constraints, and also some of the innovative things we did. So over to you, Vin.
Yep. Thanks, Jeremy. So like Jeremy said, out of this whole project here, I was mainly on the northern interchange here, and Bridge 70 was pretty much that I spent 80% of my time on, because it was the most complex bridge ever that I've ever worked on. So basically our constraints that we had, so flooding, it was done by an external consultant. We had no control over it, so they basically gave us a flood model. The pavement design was fixed from the scope of works document. Basically told us the subgrade had to be above the flood level. So that kind of fixed what we thought would be the road level underneath. Our structural designers, engineers, were playing around with the bridge design, so we gave them the worst possible scenario there was. So it was a skewed bridge, it was on a horizontal curve, and it was on a vertical curve. So the three things they hate the most. So they went away and did everything. So the whole of the northern interchange, basically, actually, the whole job was pretty much fill. So they had to import fill. I can't remember the exact amount they moved every day, but it was quite a lot. So our objective here was to keep the alignment as low as possible, which kept costs down. So going for that. So the process we took was what we do in Arup. Is basically we just develop a 2D layout first, so a functional layout. Then we talk about it a lot, go to the meetings, show the client what it may look like. They're happy with it. We started the job in version 10, and then we transitioned over to version 11 midway through. We started with version C1D. It was a 100% road design model that we went through. At first, because Bridge 70 was so complex, we could only do manual calculations, so pick 2 points, get some data from the structural engineers, back calculate, this is our vertical clearance. Is it going to work? Yes or no? Go back and change the design if it doesn't. So then we made the decision to try and create a bridge structure in 12D. We tried various methods, so draw piles and columns in CAD, see if it will come in. It wasn't very successful, so we just decided to just export the whole model, give it to the bridge engineers so they can do it in their own model. So we basically did an IFC export. The IFC Express writer wasn't available at that time, so we just did it the normal way. So we exported everything to them. Boxing when required, we didn't do too much, but we did a little bit. Utilities and drainage, so all the culverts were actually exported. On top of that, we basically did 3 separate model reviews. So we did the 12D review, so all the strings and the bridge structure in. We did another review in Bentley EcoSim, and at the same time, we also decided to do a Navisworks model, which would coordinate everything and also help us do our clash detections. Overall outcome, we basically optimized the road alignment design. We really minimized the amount of earthworks, so the client was very happy. I can't remember the exact savings we had, but it was a lot. It was a fully coordinated design of all disciplines. So the disappointing thing was we submitted our 80% design, and then they decided to give us a new flood model, so we had to redo everything, which I'm sure a lot of people have been through. But luckily enough, we didn't have to move the bridge at all. That 50 mil that we had left over, that was enough for us to just raise the road underneath. But it was a long exercise. So we only had a few weeks to go from our 80% to 100% because the contractors kept chasing us, going, "Where's our model? We want to go out there and start clearing this whole block of land." Overall, it was a good outcome. Just to show you the construction progress. So on the top left there is the Bridge 70 that I just spoke about. So all the beams were there. In the end, the bridge design was at 95% capacity. So we had to get a bridge engineer out at the Hume site to make sure everything was okay. Because Hume's hadn't done a big project like this before, so they'd never casted anything this big before up at North Queensland. And I believe they're ahead of schedule. So these are each of the interchanges. That's pretty much it from me.